This video shows a simulated takeoff and landing of the Carter electric air taxi, flown on the X-plane physics-based flight simulator. The aircraft takes off like a helicopter, with an electric motor powering the rotor, and the propellers countering the rotor torque through differential thrust. Carter's patented tilting mast is at a forward position for climbout, so that the rotor can provide forward thrust while keeping the rest of the aircraft at a comfortable pitch attitude. This is much more than an animation. X-plane simulates the actual forces on the aircraft, based on airflow, pilot control inputs, and other physics, to predict how the aircraft will behave. Proprietary software written by Carter interfaces with X-plane to simulate Carter's automated control algorithms. As the aircraft transitions to cruise, all four propellers are now producing positive thrust. There is now enough airflow over the wings that they are contributing a significant share of the lift, and the rotor can be substantially unloaded. The mast is slowly tilting aft as the aircraft continues to accelerate and the rotor becomes increasingly unloaded. This whole process is seamless to the pilot. They simply fly the aircraft, and the transition takes place almost imperceptibly. As the aircraft nears its cruise speed of 175 miles per hour, the rotor will reach its minimum rotational speed of 100 rpm, and the rotor drag is only a tiny fraction of what it would be at the takeoff rpm. The aircraft has now fully transitioned to cruise. Once the cruise segment is completed, it's time for the aircraft to transition to land. The rotor was in the slowed cruise condition of 100 rpm, but begins accelerating as the aircraft slows down. The transition to approach and landing is largely the reverse of takeoff. As the aircraft continues to slow down and the rotor continues to accelerate, the rotor produces an increasing share of the lift. This coincides with the wing producing a smaller share of the lift corresponding with the decreased airflow over the wing. Just like the takeoff, this whole process is seamless to the pilot. They simply fly the aircraft with the normal flight controls, without having to worry about any specialized controls to manage the transition. Once the pilot reaches a stabilized approach speed, they hold that speed for the rest of the approach. We'll fast forward through this portion of the flight. All of this is made possible by Carter's slowed rotor compound technology. Carter is able to dramatically slow the rotor while keeping it stable. Slowing the rotor dramatically reduces the rotor drag. And since the wings only have to support the aircraft in cruise, they can be much smaller than regular airplane wings. It's this combination of slowed rotor and small wings that enables slowed rotor compound aircraft to be so fast and efficient. We'll now return to normal playback speed. As the pilot approaches the landing zone, they are again flying the aircraft like a helicopter, with an electric motor powering the rotor, and the propellers countering the rotor torque through differential thrust. The aircraft touches down, and the flight is over.